You're going to work on the warm up and give you a little bit more time. Give some of you guys a little bit of help. A couple of guys finished already. Then we're going to take a quiz. It should be about 20-25 minutes on the quiz. And then we have notes that we need to round off the class with on graphing radicals. Okay, so today, at the end of the day, simplifying radicals and exponential functions or expressions. Add and subtract the radicals. Okay, and you need to multiply and divide those radicals, solve those radical equations, identify extraneous solutions, and graphing radicals. So everything on the quiz is up to solving. So you should be able to simplify, add, subtract, divide, multiply. All right, I don't have solving on this one. All right. So, reminder down the bottom, today's 10th, so you have your quiz, and then you have a test on the 19th, Friday, next week. Okay. So with that, I'm going to unfreeze the Desmos. You can go back to that, and I'll give you some hints on that. Okay. So, let's bring this on over. Not yet. Not there. Hold on a second. Let me. Yeah, do it like that. Okay. So let's bring this over here. All right. So there's a lot of stuff here, right? So one of the things I would do would look to sort anything that is a radical and kind of just throw those together so I can start getting space. I know they don't match yet, right? But we'll match them up. I just need to create space so I can see what's going on. So anything with a radical, I would just kind of throw into a card sort over this side. Anything with exponents, kind of go this way, radical that way, exponent, exponents. What's this? Exponents, exponents. What's this one? Exponents, exponent. Radical, exponent, exponent, exponent. All right, so we got 12 in each. That looks good. Now, my other hand is take anything that just has an x, not the x and the y. Just has an x, to see if you can find a match for that, right? So, if you don't see it, you might have to move some cards out the way until you see it. So, x squared and 1/2, x to the 1/2 power. So those two match, and then you just click the square and minimize it. So now you have more space, and I can put those back over there if I want, or whatever. So I'm looking for stuff that just has, like this one, it's just an X. I would do that one. Put these back over there. And then I'd find the one that is cube root of X and find that card. All right. So we're going to take notes on graphing radical equations. So everything we've done this year, every unit we've done, I told you they are functions, and we're going to learn how to do all the operations on the functions and learn the characteristics of the graph and relate the graph back to the equation, obviously. So if you remember the beginning of the year, get my oops. So if you remember the beginning of the year, we had a general equation, right? Y is equal to a f of whatever that function is, x minus h plus k. All right. So this is all of our functions. Remember, a is a stretch or compress. H is the horizontal movement. It goes opposite. So we're going to take the whole graph and move it opposite. And then K moves it up or down, right? So these are all the transformations that we were doing. Oh, yeah. A also flips it over the x-axis if it's negative. So these are all the transformations, A, H, and K. So the same thing applies to the radical graph, which we're going to take a look at. Okay. Let's scroll this up a little bit. So this is the parent function, square root. So this is the parent function. That is the most basic function without an a, h, or k affecting it. So the parent function is the square root of x. Okay. Now, I'll do a quick x, y table here so we can get some points. So we can start looking at points and we can start seeing the general shape. Okay. Let's start off with negative, let's see, perfect square, -1. Well, if I put in -1 into the square root, I get an imaginary answer. So there is no real solution for this to put onto the graph. So there's no real solution. So not real. It is imaginary, but it's not real, so it's not going to show up on the graph. So anything that's negative in the square root is not real. So there's no graph for anything that's negative. So if I go with 0, square root of 0 is going to be 0. So I know that point. Let's say 1 means I get 1. So 1, 1, I know where that point is. Now, since we are doing the function of square root, I want to pick perfect squares here. So 4 gives me an output of 2. So 4, 2. If I put in 9, which is the next perfect square, I would get 3. So that's up over here somewhere. So we have our points for our curve. So we want to kind of draw a smooth curve through those points. So this is what the graph would look like. Obviously, you guys can put it in the graphing calculator and you'll see a much nicer curve than that, but it will give you the same concept. So we need to look at this and fill in this information that we were doing before our other graphs. We're going to figure out whether we have a stretch, compress, shift up, shift down, left or right, right? So AHK. In this case, we have transformations. I'll write it down here, none. So there are no transformations, so this graph didn't really move anywhere. Okay, so we need to find our x-intercept. Well, we can look on the graph. That's going to be at 0, 0, so that's where we touch the x-axis. Y-intercept's also at 0, 0. That's where we touch the y-axis. Domain. Now, the domain is our x values. We have no negatives. It starts at 0. So our domain starts at 0. 0 is included, square bracket, and goes to infinity. The range, there are no negatives on this graph. So it starts at 0 and goes to infinity. End behavior. Notice this is a little bit different, right? Before we were going to infinity, now we're going to 0. Okay, you might see it sometimes put in as infinity, okay, but you're limited on the output because you have no negatives. So that means as we go towards 0, as we approach 0, the y, the f of x, actually goes to 0. As x goes off to infinity, y goes off to infinity for the parent function. All right, so let's move down to number 2. So that's the parent function where we didn't move anything. We didn't translate it anywhere. So now let's look at number 2. Okay, parent function. We're still doing the square root function. That's the function. Square root of x. That's the parent function. Okay, transformations in this case. A is equal to 2, so we have a stretch of 2. And h is going to be equal to 4. Remember, h goes opposite. So instead of being at 0, 0, we're now going to be at 4. And we have a stretch of 2. So if I go 1 to the right, which would have been a square root of 1, now we need to multiply it by 2. So we're at 5. You put in 5 here, you get 1, which is 1 times 2. So 5, 2. Or, yeah, 5, 2. Yes, I am. There you go, guys. Thank you. All right, so now let's see. If we go 4 spaces, that's going to put us at 8. That would have given us 2 times 2 would give us 4 up there. Okay, and then we can fit the curve into that. Okay. So let's draw a nice smooth curve into there. And then it goes off to infinity. All right, so our x-intercept is at 4, 0. Since we shifted to the right, it doesn't touch the y-axis. So there is none. So there is not a y-intercept. It doesn't touch the y-axis. Domain, well, domain or our x values starts at 4. And then they go to infinity. Range from the bottom of the graph to the top of the graph. The bottom of the graph is at 0. And then it goes off to infinity. Now we can talk about our end behavior. Notice once again, it's approaching 4. As we approach 4, our graph goes to 0. The y value of the graph goes to 0. As we go off to positive infinity, it is going off to infinity. So we had our stretch of 2, our shift right of 4. Right, so probably should add right 4 here. So it goes right 4. Okay. So all this should be very familiar. All this stuff down here should be very familiar, right? We're just kind of playing around with a new function. Okay. Let's look at number 3. Parent function, square root. Square root of x, parent function. Transformations. Well, now a is equal to -1. So that's a flip. And 3, that's k. K is equal to 3, so it goes up 3. This is not underneath the radical, right? This is outside the radical. So there's a plus sign, but you see it stops before the plus sign. So that is not h, this is k. So the grouping symbol stops before the plus sign, so this is k, not h, not under the radical. Okay, so you need to be very clear when you look at them, or even if you have to write the equation, you want to be clear. Okay, so let's look at our x-intercept. Well, what did we do? We flipped over. That doesn't really affect our 0. And then we went up 3. So up 3. We're going to have to work on getting the x-intercept in a second. Okay, so now it's flipped over, so it's going to kind of curve down, right? So if it's going to curve down, if I go over 1, that means I go down 1 instead of up 1, right? So if I put in 1, in other words, if I put in 1, I have -1, so that puts me at 2. So it's kind of like doing a data table, right? I just kind of know the points. Perfect square at 4. Let's be down there. And then if I'm at 9, I'll get 0. Because 9, square root of 9 is 3. -3 plus 3 is 0. So that's my x-intercept is at 9, 0. My y-intercept, we moved up 3, so that's going to be at 0, 3. Yeah, let's put our curve in here. Oh, okay, I missed. Domain, well, it starts at 0 and goes off to infinity. Starts at 0, touches 0, and goes to infinity. The range, well, the bottom of this graph now we're going down. So the bottom is at -infinity. And then it goes up. The highest point we're going to have is going to be at 3. and we touch 3. So it goes from negative infinity to 3. So let's look at our end behavior. As we approach 0, the end of our graph here, the y is at 3. And then as we go off to infinity, this graph is going down. So we're going to negative infinity. Okay, so we have done a stretch, a flip, a shift up, not necessarily shift down, and then, and shift right and left on the problem above. Okay, so those are square root graphs. Let's take a look. This one's a little bit different. This is cube root. This is cube root up here, so it's x to the third. So this is a cube root. Or not x to the third, sorry. Third root of x. So the parent function is the cube root of x. And we're going to graph that. So if it is the cube root, now I do have negative values I can use. So let's do a quick XY table. So we're looking for perfect cubes. Negative 8, perfect cubed, right? Negative 1, 0. All these are perfect cubes. 1 and 8. The next one's like 27. Doesn't fit on our graph, so I'm not going to use it. So I'm going to use these 4. Okay? And this is the parent function, so there are no transformations. We're not worried about that. So negative 2 times itself 3 times will give me negative 8. Negative 1 times itself 3 times gives me negative 1. 0 is just 0. So this is going to be positive 1 and positive 2. So let's put these points on the graph. Negative 8, 2. Negative 1, 1. 1, 1. 0, 0, 1, 1. 8, 2. So this graph, see if I can do that a little bit better there. Comes up and makes a nice smooth curve going through. All right. This is enough to tell us about end behaviors and all that good stuff. So the x-intercept, it crosses at 0, 0. The y-intercept, it's at 0, 0. We haven't shifted it up, down, left, right. So it's going to be at 0, 0. Domain, well, this goes off forever towards negative infinity. This goes off towards positive infinity. So it's all real. I'll do the double bar R for that one. And the range, let's say this goes down forever, this goes up forever. I'll do double bar R for all real on that one. Now our end behavior, as I go to the left, remember negative infinity means left. So as I go left, I'm going down to negative infinity. And then, let's take a look, as I go to the right, it's going to continue to go up. Really slow, but it's going to go up forever. So that goes towards infinity. Right. So for domain, this is all real. It's going from, I used a slightly different notation. Remember, we have a couple different notations for that, right? We can write the words all real. We can use double bar R, which is all real. So negative infinity to infinity is the exact same thing. That's what double bar R means. Okay. All right. So now we got a couple things going on here on this one, right? So parent function, still a cube root, still a cube root. transformations. In this case, we have A, which is -1. That's a flip. And we have H. It's going to be 5, right? Not -5. Well, -5, excuse me, not 5, because it's going to move left. Left 5, because H goes opposite. H goes opposite. Ooh, I wrote this. That's funny. Okay, so let me fix that right here. We're cube function, not the square root of 3. Cube function, so got a little ahead of myself there. There we go. Okay. So it flips over and we shift left 5. So our point 0, 0. I always kind of start with that point. That's the easiest point to move. So we move left 5. Flipping doesn't really affect it because it's on the x-axis. It affects all the other ones. Right? So remember when we were on the left side, if I went over 1, down 1, that was like -1, -1, it's going to flip it over, which is going to make it 5 up here. Okay. Hold on a second. So remember when I went to the right 1, I would go down, up 1. Now I have to go down 1. Okay, so let's find our perfect cubes. The other one was 8. So if I go 8 spaces from the 0, 0, right, this point, that's going to be, let's see, that's 5, 6, 7, 8. That's going to be a -2 now instead of a +2. So it's going to drop it down. So let's get our curve kind of in here. Kind of goes like, ooh, that was almost a perfect one there. Okay. All right. Question that I have in the chat is about -5. H always takes you in the opposite direction. Always takes you in the opposite direction. Let's, yeah, let's kind of go back a little bit here. All right, let's talk about H inside the function. So I'm not going to use the square root function. We're going to use just a regular, what function should we use? Let's use quadratic. Okay, so if we had a quadratic function, this is the first ones we worked on, right? And we had x plus h. Let's make it numbers. We use 5 since we have 5. 5 squared. We're not going to put a k. We're not going to move it up or down. Okay. I need to know where the x-intercept is going to be for this. So at the x-intercept, that means y is equal to 0, right? Now I got to get rid of this square, so I'm going to take the square root. Let's do that in a different color. Take the square root of 0. So if I take the square root of 0, I get 0. And that's equal to x plus 5. Well, I'm trying to find x, so I have to subtract 5 from both sides. So when I subtract 5 from both sides, I end up with x equaling 5 to make that statement true. So h, when it's inside the function, is going to force everything to go the opposite direction. It's sneaky h. So it goes opposite. Right? So for our h, we're down 1. So for our h, it's going to go opposite. So that tells me where the point is. Because this point is hk. This point is hk. So the original point that was at 0, 0, which is hk, that's the point, has moved to here, hk. Okay, so our x-intercept is going to be at -5, 0. Y-intercept, a little tougher to find the y-intercept. We got to do a little bit of work for the y-intercept. All right, so we're going to take this equation, and the y-intercept, x is going to be equal to 0. So let's write this down. Y is equal to negative cube root 0 plus 5. So y is equal to negative cube root of 5. Okay, so the negative cube root of 5 is, I don't know, it should be a little bit higher than 2. It's in between 1 and 2 somewhere. But we're just going to leave it like that as the intercept. So negative cube root 5, comma, 0. Ooh, I wrote that backwards, didn't I? I totally wrote that backwards. It's actually 0, because y is 0. Negative, excuse me, x is 0. Negative cube root of 5. Because that's the y-intercept. Okay. Domain didn't change. Still using all those values. Range didn't change either, right? Still goes up forever and ever and ever. So now, the left side now is going off to infinity. It's going up. And the right side is going down to negative infinity. Okay. Let's take a look at this one. Now we have a is equal to, well, parent function. Let's do that first. Cube root x. Now we have a is equal to 1/2. Okay. The 1/2 is going to compress it. So the 1/2 will compress it. So that means it's not gonna rise as fast. It's gonna rise half as fast. Okay. K is equal to -4. So we shift down 4. And then we can find our intercepts and everything. So let's get this on the graph. All right. So starting at 0, 0, we have a transition down of 4. So K goes down 4. So we're here. We didn't move left or right, we just moved down. The stretch doesn't really affect the point that was at the origin, but it does affect the next point. So remember in the parent function, if I go to the right one, right, the output would have been 1. Now it's going to be 1/2. So it's going to be in between. And this one's going to be -1. It's going to go in between. All right, so it's at -4.5. Okay, our next perfect cube was 8. So let's go over 8, and 8 would have given me an output of 2. Now it's just going to give me the output of 1 higher than where the origin is, so it's 1 higher. And then 8 over here is going to be 1. Okay, so let's kind of sketch this graph. Let's make the last one a really good one. Oh, it shouldn't be flat. It should be a curve. It should curve up. It shouldn't run flat. But okay. You can put it in on your Desmos or your TI and you'll see a nice curve. It's not flat. It's curved. All right, so the x-intercept, oh my goodness, the x-intercept is going to be way out there somewhere, way out there, right? That's where y is equal to 0. So we have a little bit of work to do for the x-intercept. So let's make y equal to 0. That's going to be 1/2. And then we have cube root of x minus 4. All right, so let's say we need to, first of all, move the 4 over. So this is just like solving, right? So it becomes +4 is equal to 1/2 cube root of x. Well, it's actually not that far. It's actually fairly close, isn't it? This is a 3. Okay. So if I multiply by 2, I get 8. And then I get 2. Because this is equal to the cube root of x. So that means I need to, actually it's really, really big. I need to take the third, I don't know if you guys can see that. Let's move that up here. Okay, so I can write it a little bit larger. So 8 is equal to cube root of x. So that means I need to take it to the third power. Take 8 to the third power. So that means x is going to be equal to, I don't know, what's the third power of 8? I don't know. That's a calculator problem for me. 64 times 8. Okay, so let's say 8 raised to the third power. Okay, 512, way out there, 512. Can't see it on the graph, but we can definitely find it. So x-intercept's at 512, comma 0. Okay, y-intercept, we know where that is. That's going to be at 0, -4. Domain doesn't change. Range doesn't change. In behavior, well, look at this side over here on the left side, -infinity. Left side going to -infinity. Right side, it's going off to infinity. Okay. And here you go. Homework, radical transformations. It is in Desmos. It is in Desmos. I'm going to